In this video, we're going to discuss the potential errors that can be made from a hypothesis test. These are called type 1 and type 2 errors, not very creative names, but the idea is that we are trying to infer to a population parameter. That parameter might be the population mean or the population proportion. And that conclusion, remember it was a reject or a do not reject the null hypothesis. That conclusion is based on sample data. And we know that sample data is subject to sampling variability. In essence, there's a chance that that sample was not very representative of that population. So there's a chance of making a conclusion error. And this is not like a mathematical error, like, oh, whoops, I forgot to move the decimal over. This is an error because of the essence of sampling. And when we collect samples, we hope they represent the population via random sampling, but there's chance for sampling error to occur. So this is an error based on sampling, not necessarily a whoopsie kind of error. Let's look more closely at a type 1 and then a type 2 error. A type 1 error is like a false positive. This is possible when we reject the null hypothesis, but we should not have. So when the data suggests to reject the null hypothesis, but this is incorrect, a type 2 error is akin to a false negative. And a type 2 error could occur when we do not reject the null hypothesis. So the data suggests that we do not reject the null hypothesis, but this is also incorrect and we should have rejected it. Now, we never know if an error is made, and we never know if we've made the correct conclusion. We never know if our conclusion was correct or incorrect, because our conclusions are based on sample data. And that's usually all you see in your study is the data from your sample. We don't have population data. If we had population data, none of this even matters. But it's possible that these errors are made, and so it's worth discussing the consequences of those errors and how often they're expected to occur. So while we never know if our conclusion was correct or possibly erroneous, we do know how often they are committed. The probability of a type 1 error is given by a small number, right? We don't want to make errors that often, but this small number is alpha. Remember that? This alpha first showed its face from confidence intervals, right? From confidence intervals. And usually that alpha is 0.01, 0.05 is actually the most common, or 0.10. So it's a small number, and that's something that we have control over, right? And there's pros and cons to these values, and partly why we say 0.05 is the most common. Remember that that connects to 95% confidence. And this one corresponds to 90%, and this one must be 99%. So we say that 95% confidence is sort of the most common because it's sort of the middle of those values. There's more to it, but that's really all we need to know. So the probability of making a type 1 error is something that we have power over because we usually choose alpha. The choice is usually 0.05, and that's sort of the default, but it can be altered, right, one of these other values based on the consequences of a type 1 error. We're going to discuss some of those consequences shortly, and before we do so, I want to mention that alpha should be chosen prior to any analysis, sort of in the hypothesis stage, because you don't want to bias your results. One last thing before we go into an example is that we have the ability to choose alpha, which corresponds to the type 1 error probability. But a type 2 error is a bit more difficult to calculate. It depends on a lot of factors. So what I'm just going to say is that type 1 and type 2 errors are inversely related. I like to draw a little picture here. Like if you had a seesaw, remember that little fun playground toy, right? If you had type 1 and type 2 sitting on the seesaw, if you said, well, hey, I have choice over my type 1 error rate, why don't I just make it super small? Well, that would make your type 2 error go up, and vice versa. So they're inversely related, and in part, that's kind of why we have that default value. So let's go and look at an example to illustrate the consequences of a type 1 and type 2 error. So let's look at an example. And in the previous video, we were looking at these cheetahs, and we established some hypotheses about their first-year survival. And we're going to consider the consequences of type 1 and type 2 errors associated with this situation. Let's look at some of the potential consequences of a type 1 error when discussing this hypothesis from earlier. This was the hypothesis that the proportion of cheetahs that survive their first year has decreased from 20%. And this was the conclusion that corresponded to a rejection of the null hypothesis. So this was a rejection of the null hypothesis. And let's discuss some of the consequences. Here we are claiming that the proportion has decreased. But if this is an error, then the cheetah survival actually has not decreased. Cheetah survival proportion actually has not decreased, right? Because here we're saying that the decrease occurred, but if that was an error, then that is not so. So what could be a consequence? Well, you might imagine that If this was your conclusion, and maybe you are part of a governmental agency or an NGO that is looking out after wild animals, and your conclusion was, hey, they're surviving at a much lesser rate, then maybe you went and proposed higher conservation efforts, more conservation. Maybe you ramped up educational programs to educate the public about cheetah life histories. Perhaps poaching was an issue, and now you're going to spend money to enforce anti-poaching. And guess how all of that probably has to get funded? This probably is going to need to be funded with, I don't know, maybe increased taxes. So if this was your conclusion over here, that the proportion of surviving cheetahs is decreased, maybe you want to do something about it if that's a part of the team that you're on. But if that sample that conclusion was based off of was inconsistent with the population, then maybe that proportion has not increased. So the consequence here is that maybe there was a lot of extra effort and a lot of money spent to help facilitate the survival of cheetahs, but it wasn't really needed because their survival rate did not decrease. So that could be a potential consequence of a type 1 error. Now let's consider what potential consequences could happen with a type 2 error. So I'm going to scroll down here. Let's look at this hypothesis again about the proportion decreasing for the first year survival for the cheetahs. And here I've got the conclusion that we stated. This conclusion was when we did not reject the null hypothesis. That is when a possible type 2 error could occur. In this conclusion, we stated that there is not evidence that the proportion of surviving cheetahs in their first year has decreased. That there is not evidence for that. If that was the conclusion, then you might think, okay, well, seems like they're just doing what they're doing. There's no decrease. The decrease would be alarming for their survival rate. So the action based on the sample might be, let's just keep on keeping on, business as usual. However, this conclusion is erroneous. So actually, the first year survival is decreasing. So what's the consequence then? Well, possibly if the first year survival is decreasing, then that might mean that there are fewer cheetahs making it to an age of maturity, and the population of cheetahs could be dwindling, and that can put a threatened species in more danger. So in all of these scenarios here, there was the conclusion, there was the action based on that conclusion, and I'm just, making stuff up, but I think it's feasible. Then here is the reality, but that's unknown because that was not represented in the sample. And then over here is the consequence. That same sort of system applied to our type 1 error example up here, where based on this conclusion, which is based on sample data, here this might be the action that was taken, but it was not representative of reality. That conclusion is not representative of reality because that was unknown. And then over here we've got the consequence. So the choice for alpha is supposed to be based on what these consequences are. And usually alpha is 0.05. It's sort of the middle ground. But if the consequence for a type 1 error was very unsettling, you might lower that alpha. Because remember, that's the probability of a type 1 error. Similarly, with a type 2 error, if the type 2 error was very unsettling, how could you possibly lower it? Well, because there's a teeter-totter relationship with type 1 and type 2 error, you could make alpha a bit larger, and that would make the probability of a type 2 error smaller. That's going to conclude this video, and in the next video, we'll do another example, but from the homework.